I'm your host. Let me introduce myself. My name is Divyansh Khandelwal. I'm from India, as you might have known by now. And currently, I'm doing third year of my BTech, bachelor's from VIT Vellore. I've been involved in a lot of community work with the developers, helping them with the beginners to get started in tech. And I've been GitHub Campus expert for about a year now, helping student communities in the college and in India generally with the hackathons and other stuff like that. Other than that, I am a software developer at Spike. So yeah, moving on with the session breakdown. So first of all, we'll have a small talk on DevOps, where I would like to set the mindset, the current mindset of you before we actually dive into DevOps, because having a correct mindset is very important when it comes to practice DevOps. And following that, we'll have a live coding session in which we'll build an app and try to implement the good practices of DevOps on that particular app and make it from development to production. And if time permits at the end, we'll definitely try to have a Q&A session with you. So yeah, Mythbusters. The thing with DevOps is that there is a lot of myths, a lot of false notion when it comes to DevOps that revolve in the dev communities. So it's very important that we first of all clear those notions before we actually dive into what DevOps actually is. So myth is that DevOps is a programming language or a framework. Well, no, DevOps is not a programming language or a framework like React or Node.js. DevOps is not that. Okay. DevOps is a set of automation tools. Now, this is a very common notion that people have. They think that, okay, if I learn particular set of 5 to 10 tools, automation tool, I'm a DevOps engineer. Well, that's not the case. I'm sorry. That's a myth. Now, there's a roadmap that I can follow to become a DevOps engineer. Well, no, there isn't any roadmap which can lead you to become a DevOps engineer. DevOps is a very need to know basis thing which you implement when you actually want to implement it. And finally, we come to having DevOps in your title means that you are doing DevOps. Well, no. So, what exactly is DevOps? Now, I like to explain DevOps with the help of 3 Ps. The first one says that it is a philosophy. Now, what do I mean by philosophy here is that DevOps is a mindset that you need to have while solving a particular infrastructure related problem or an issue. You need to have the correct mindset as to how to approach this problem and what could be the best possible solution to this. Okay. The next P or the second P is that it is a practice. Now, what do I mean by practice is that DevOps is something that you implement on an everyday basis, and it is so common that it becomes second nature to you. Let me give you an example here. For example, the use of version control like Git or GitHub or GitLab, things like these is something that developers now have a second nature to, commit the code as and when they are coding. So that is also DevOps because that's a good practice. That's a good habit to commit your codes to have good proper commit messages. So that comes under DevOps. And it is a for purpose. Now, this is very important because you don't do DevOps just for the sake of it or just for the fun of it, right? DevOps has a purpose. Everything that you do under DevOps has to be have a purpose why you are doing it and how are you making it efficient. So these 3 Ps really is what defines DevOps for me. Now looking at the journey of DevOps. So in a general project, let's say we start building a project, there's a development team, right, which is required to develop the microservices and which is required to build the infrastructure, like the basic app, the basic working model. And then there is the operation teams whose job is to basically launch that microservices or the app that the developers build to the production environment, right? So production environment as in like deploying it to the servers. So DevOps is basically a journey from development environment to the production environment. As you can see, DevOps is built up of two words, which means development and operations. This is how DevOps was formed. Now, the job of a DevOps engineer is to make sure that this journey from development to production is smooth and is efficient as possible, and also to automate it in every step as they can, right? So now this is like the de facto logo of DevOps, and it beautifully represents the complete stages of software development lifecycle. And we'll use this to try to get an understanding of what DevOps is. Now, this journey begins with the planning stage. Any project that you start working on, you basically sit down with your friends or the team that you're working with, and you plan that project, right? So where can we make this, how can we make this efficient? We can use something like Jira or Notion, or you might have heard Linear or Taskade. So these are few tools that can help you to jot down your planning and the brainstorming session, so that once you move ahead to coding and building phases, it is very easy to refer them back, and you make sure that you don't skip out on any points that you planned. So using a good tool for Scrum or a planning documentation is also a part of DevOps, because it makes your process and your project efficient. Now, as you build the code and as you code, a version control is a must. For those who don't know version control, it's basically where you have the history of the commits and you have the history of the codes that you have pushed. So a very famous version control is GitHub, others are GitLab, Gitbucket. So this is also good practice to have a version control in your ecosystem. And as you build, you definitely need a testing environment, right? Where you can test your codes, that is there any bug in it, or you can fix those bugs before you deploy it. So something like Travis or Jenkins come into picture at that point. So whatever we have seen till now, these 4-5 tools, these come under the development phase, which the development team can use to enrich their developing experience. Now, as we move on, we come to the blue area. Now, this blue area is the operations side, right? So we are moving towards releasing the product to the production environment, right? And how do we do that? Well, we have something called as containers. Now, you might have heard this containers a lot of time and fumbled upon it, but now you'll get it clear. What containers is basically, it basically packs all your environment in a virtual machine, as to say, and it helps you ship that particular product or that microservice easily across multiple systems or servers. So a container management tool like Docker or Cryo can be very useful in such case. So this comes under the release part. Now, once you have those containerized applications, you would like to deploy it, right? And you would like to automate this stuff a bit. So there we use something as GitHub Actions. And GitHub Action is a fabulous tool to have it in your build, which can automate a lot of tasks for you, and you can deploy your applications on cloud providers like AWS or Linode or DigitalOcean. So yeah, my personal favorite is AWS. So yeah, you can deploy it anywhere as you like. Now, once you have deployed it, you need to operate on it, right? Because there is maintenance. The job is not over yet. Once you have deployed it, you have to maintain it as well. You need to be sure that there is no downtime in your application. So for that, you can use something like Kubernetes. Now, it's not very essential or a must-have tool, but yeah, tools do exist. So Kubernetes is one of them, which can help you in container orchestration for helping you manage your containers. And then you can automate all of this using Terraform. So Terraform gives you infrastructure as code. So you can have few scripts and all of this process could be automated. The whole infrastructure setup, the setup of your servers, container orchestration, and all of that can be done by Terraform. Now, once you have all this, you definitely need a monitoring solution because you want to monitor your application, like how often is it crashing? Is it crashing or not? Or are my customers getting the right status codes or something like that? So you need a monitoring tool. And one such tool is Grafana. You can use Grafana for your monitoring applications, which can monitor your containers and give you very detailed logs, as to say. Yeah. So this is like a continuous journey that a software development life cycle has. So you start from planning, you code, you build, you test your builds, and then you release. And once you have released, you keep on adding to the product, right? The version 1, the version 2, the beta version, the alpha version, and this keeps on going in the loop, in the infinity loop. And these services will ensure that your journey is very smooth. So if you're thinking, what am I doing here? Don't be, just hold on for a second, because I know that these all new terms could be very overwhelming for you. But trust me, it's very, very, very fun to play around with these tools. And that's what we're going to do next. We are heading into live coding session now. And here's the task list. So we'll be building a React app. I hope you have experienced React in the previous session because I saw that they were quite based on React apps. So it'll be easy for you to pick up. Then we learn something about Docker. We'll basically try to containerize our React app. So containerizing the microservices, yeah. And then we'll build a EC2 instance on AWS. Now, AWS is a cloud provider, cloud service provider. They offer a lot of features which are paid and some are free. So we'll be using a free tier for EC2 instance. So you can also follow along and you won't be billed, right? Now, once we build the EC2 instances, we'll try to deploy our containers that we built here on those EC2 instances, right? And once that is done, we'll set up a CI/CD pipeline with a GitHub action. So if I go back to the diagram, we'll be using GitHub. We'll be using, we can skip the test suites for now because it's just a demo thing, but we'll be using Docker. And then we'll be using GitHub Actions, AWS. Yeah, that's it. So we'll be using these few tools to make you understand how it feels to work in DevOps, how it feels to, make the process smooth. So yeah, let's get. Oh, do you have any questions at this point? Yeah, the session will be recorded, Devin. Cool. So yeah, so those who are following along, you can create a new working directory. So I'll just create a new directory here. Yeah. So let me increase the font size for you. Yeah. Now we'll use something as create React app. It's a cool utility that helps you create the boilerplate of the React app in just seconds. And we'll name it as codebar. So yeah, this can take around 2 to 3 minutes for it to create the boilerplate and everything. So yeah, we'll get back to it. And in the meanwhile, I would like everyone to make a GitHub repository. So you can easily create a GitHub repository if you go to your profile, github.com, and there's a new tab here. You can go to the new tab, give your repository a name, and just create it. So I already have it created for you, like for this demo. I'll be using that repository. You can create your own repository and copy the GitHub link from here. Okay. So yeah, still building. In the meanwhile, like I would like to show you how AWS console looks like. So this is my demo AWS console. And if you look at the services, so there's a lot of service that AWS provides. The names can be confusing at first, but once you start getting into AWS infrastructure and the services, it'll be easier. So we'll be using EC2 instances. These are the compute modules that AWS provides. And these are basically like small VMs or virtual machines that will be running, which AWS provides us to work with. So in the meantime, we'll be creating a AWS EC2 instance for us to launch our React application feature. Okay, so we'll do launch instance. So here are a lot of distros or images to choose from. Like you can choose macOS or Ubuntu, Windows, whatever, but we'll be sticking with Ubuntu 2004. We'll be choosing T2 Micro. So T2 Micro is something that AWS provides us for free. We will not be billed for this machine. If you choose any other machine, you will be billed. So make sure that you choose this free tier eligible T2 microservice. Next, we'll configure some details. You don't need to mess anything here. We'll add storage. Our storage is currently 8 GBs, which is more than sufficient. We'll add a tag. Generally, I like to add a name tag, which I'll name it as codebar. And then we'll go to security groups. Now, this is important. So here, we are configuring what all ports will be available to that EC2 instance to talk from the outer world. So that EC2 instance, that virtual machine by default only has a SSH port available, which is 22. But we want to host a website on it, right? So the default HTTP port is 80. So we'll add a new rule. We'll select HTTP from here. Here is HTTP. And as you can see, the port is 80. And we'll also add HTTPS, which is secured HTTP. And the port is 443 for that. Okay. Yeah, that's it for now. But if you have any other services that you wanted to host, you will simply keep on adding rules and the ports range for that. Let's say you had a MongoDB instance installed and you wanted to listen. So you can have a custom rule here, custom TCP rule, and provide the port for it, which is 27017, I guess. Yeah, but we don't need that right now. Just letting you know that this is also an option. So we'll review it, and yeah, looks good, and we'll launch it. So now this VM is something that we will connect via SSH, which is secure shell. And for SSH, you need a key, that is RSA key. Okay. Now I already have this key in my system. You would probably choose to create a new key pair and store that key safely. Okay. That is very thing that you shouldn't share with anyone. Okay. Cool. So in the meanwhile, our instance is launching. It'll also take around 5 minutes to launch. And I hope our React app is built, which it is. We'll go to our, what was the name? It was codebar, yeah. So we'll cd into codebar, and let me just do ls. Yeah, we'll install the npm packages, which you can do by npm I, a short form for npm install. it will automatically install every required node package. So I also have a README file with all the steps for you so that you can follow along if you miss on something. I'll edit this and update it with the README file, and I'll push it so that you can follow along. So we had our GitHub repository built. Now we'll initialize it. So you can do git init, initialize the MP repository, git, sorry, my bad. Yeah, git add origin. Wait, you know what? I'll just use a tool that I built a few days back. And we were at development, codebar. We just delete our git. Yeah, let's use a utility that I have. Git init and master. So yeah, this will basically initialize an empty repository for me. And let's do git status. Yeah, so now I'll just add these files, git commit init. Okay, wait. Add failed. Let's see what's happening. Yeah, I think we are set up on branch master, which looks correct. We'll do git add. Wait, this is weird. Does not have a commit. Check out. Let's just Google our error. Oh, do I need to pull it first? Oh, it couldn't find master. Okay. Well, we are stuck here with GitHub, which is kind of way never happened before. Anyways, we'll move on. We will move on. You know what? We'll just delete this repository and create a new one so that we have a fresh start, because I was doing some things with the secret in this repository and I think that might have something to do with it. So we'll just delete this one and create a fresh repository. So yeah, we name it as codebar DevOps public, and yeah. So we'll copy our HTTP. Oh, I got it. So we were copying the SSH part. My bad. I'm really sorry about that. Yeah, we were copying the SSH part. So we'll do get init and master. Now let's do git add. Very wow, this is amazing. Anyways, so let's do let's try to start a React app. We can do that by looking it into the looking at the package.json file. In the package.json file, basically you have scripts, and in the scripts, it basically tells you what all are the existing scripts that React has provided you. Now we have a start script which lets you start the app, and we can run the script by npm start. So yeah, it generally takes around a minute. Yeah. So yeah, here we have the default React app. Now we'll try to edit it a bit. Let's personalize this with codebar, and we'll want a codebar logo for it. We'll go to images. Let's just be sure to take a PNG. Here it is. We'll open it in new tab. Open image in new tab, and we'll copy the link, right? And we'll edit the what is this? Yeah, we'll edit the app.js for the logo, for the source of the logo to be a URL. We'll paste it here, and we should be seeing the changes in real time. Now this rotating thing is not very good, so we'll comment out that part. I guess it should be in CSS or keyframe. Yeah, it's a keyframe. We'll just comment it out. Yeah, there we have it. We have a dummy kind of thing React app already. Let's just change the href here to point to codebar.io, and let's just change it to where do we have it? Yeah, that's it. We'll just change it to codebar. Fantastic. So any questions at this point? Okay, I missed the space and get in it. Okay, I'll check that. Yeah, get init, initialize untitled repository, we'll go to HTTP, copy. Yeah, now we can add it. I'll do a git commit, which says init, and I'll push it. Git push origin master. Okay, I need to give the config. So git config credential dot helper store. This will do with the username, basic the logging in of the GitHub, and now we'll push it to the master. So yeah, now we have it on master branch. I have a README file for you to follow along. So if you are lost somewhere, you can use this file. I'll just paste the link here. And we have the GitHub repository initialized. So here it is. Now our app is ready. As you can see, let's say this is a demo app that we want to push to production. Now we'll be moving towards building the Dockerization part of it, building the containerization part of it, and we'll try to move this to production. Okay, so let's just build a Docker file now. Now, Docker, what Docker is basically it helps you containerize your application. So that common problem which says it works on my machine, that is something that Docker helps to solve. Okay, so Docker is a great tool to work with, and you can use it for your local development environments as well as a production environment. So we'll be using that. So I actually have the Docker file built for you, and we'll be going line by line of what this file does. Okay, so make a file called Docker file, literally Docker file with a D capital, and paste this. So what this file does is basically it builds your container. Now, how does it do? It takes a base image. Now, base image is something that Docker already has in the Docker hub. You can choose any. We are choosing a node image here because we're dealing with node package managers and all of that. So node base image already has npm and these stuff pre-built, pre-installed. So we don't need to do extra effort. Now, the working directory is the directory that inside the image we'll be working on. So this is /app. Now, the next step is basically to copy copy package.json file to this directory, to the working directory. Okay, so we'll copy our package.json. This is a very important file when it comes to node packages. So we'll copy this file to package to the app repository, and then we'll copy package.log.json. Once you have package.json, we'll do npm install, because npm install will look into package.json file and install the npm modules, right? Now the next step would be to copy everything else. Okay, now these public, these readme file, .gitignore files, on all the files in the app directory, and then we'll do npm build. We'll run npm build. What npm run build does is basically it creates a build of your React applications. It compresses and gives you minified files for the React app. Once that is done, we'll take a nginx image. Now, nginx is a complete new topic in its own thing. We need a dedicated session for that, but just letting you know that we need an nginx thing, and we'll use this base image, modified base image, as the base image for nginx. We'll expose a port 3000 here. Okay, so our application is running on port 3000, as you saw, localhost 3000. So we need to expose that port. So here is where we define that, and then we'll copy the nginx default.conf. Now this is something that is very specific to nginx. We won't dive deep into nginx right now, but just letting you know that this is a file that we need to add to the nginx directory. We'll make a folder called nginx, and we'll have a file called default.conf. Okay, and we'll just paste it here. Don't worry, I know that you won't be having this file right now, but I will be uploading this code in the repository, so you can have you can refer to it later. Okay, now once a Docker file is set up, we need a Docker compose file as well. So Docker compose file is basically a sub file for Docker files. Basically, Docker files, Docker Compose files let you build many containers in a single file. Otherwise, you will have to build each and every container with one step at a time. Now, let's get the Docker Compose file here. We'll name the file as dockercompose.yaml. Okay. And let me go through this file once so that you can understand it. Now, this version is basically a Docker Compose version, and the services is the main thing. Now, services define what all microservices that we are gonna have in our Docker Compose file. What all containers do we need? So right now we have two of them, which is one is front end, and the second one is the MongoDB database. We are not using MongoDB right now, but I'm just letting you know that this is the way that you set up a database in a Docker Compose. So coming to front end part, now we are telling Docker Compose, hey, I need to build an image. Now, where do I build it from? So the context of the build is the directory where you want to build it from. So right now, our context should be this because our Docker file is adjacent to Docker compose.yaml. Okay. And the container name is something that you can refer later once the containers are started. Okay. So volumes is something that maps your working directory inside the image. Now, generally, this isn't possible because once a container is built, it's like a small VM in its own self, and it doesn't know what all things are present on the host machine, what all file directories are there. So we use something as volumes in that case, where for the development environment, we need to have volume so that we can use Docker in the development environment. So our context would be /, and it will copy everything to user source app inside the container. Now, this context is what we are having on host machine, and this context is what we are having inside the Docker image. Okay, and then we'll ignore the node modules. So when you don't provide a host machine context and you just provide it, that means that you're ignoring that part. So we don't want the node modules to be affected. Okay. Now comes the ports. So here are the ports. As I said that we will be working with 3000 port and we need to expose it. So this basically gives you a port mapping from inside that container to the host machine. So it says that, okay, map my localhost 3000 from the host machine to localhost 3000 inside the container. Network is something that helps in inter-microservice, inter-image networking and communication part. We won't dive into it. And this is just the Mongo thing. Same thing. We'll choose an image. Now, in this case, we are not using a build and a context Docker file because the Mongo image is already available on Docker Hub. If you do not provide any context or build, what Docker Hub will do, Docker Compose will do, it will search this image in Docker Hub. And if it finds, it will pull it. Okay. And then we are creating a volume for the database. This is basically a persistent volume so that our database sits on the host machine and not inside the container, because containers are very prone to get destroyed. And if a container destroys with the data inside it, you will lose your data. So that's why we need a volume for a database, which enables us to have persistent database. And Mongo runs on port 27017, which we have mapped like this, and then the networking part. Okay, so that's it for the Docker compose.yaml. Now, moving on to our GitHub action. So this is something that is very, very powerful. Okay, we'll create a new folder called .github, and we'll create a new folder inside .github called workflows. GitHub calls GitHub actions as workflows, and you can trigger workflows. We'll see in a bit. We'll call this as deploy.yaml. Okay. Okay, so here we have a GitHub action in picture. Now what this GitHub action is, basically it helps you automate the task. It helps you to do CI/CD, which is continuous integration and continuous deployment on your apps. It basically reduces your workload, and we'll see how. So GitHub action basically comes in jobs form. So we are defining jobs here. Basically, what is the job that is required by the GitHub action to perform? Now, its job is to come, uh, basically use this as the base and do a Docker login. So we'll first log in to our Docker hub. And once we do that, we want to build the Docker image from the file, Docker file, which we just built, and push it to Docker Hub. Okay. So this everything will be done inside a virtual machine that GitHub provides. GitHub actions are run inside a virtual machine that GitHub provides you. And we need to tell that machine, okay, now build the Docker front-end image for me, and we'll give the command of Docker build file, Docker file, which is what we created right now. And then we tag it. Now tag is basically a name that will be present on your Docker hub. Okay, like we have a name for your GitHub repositories, you have a name for your Docker hub images. Now this is my user ID. You should replace noobmaster147 with your Docker hub ID. Okay, and then we'll add the name to our image, which is codebar frontend. Okay. Once we have the image, we will push it on the Docker. So which will be Docker push noobmaster, which is my handle. You should use your handle here. And once the Docker images are pushed, we'll deploy it. We'll move on towards deployment of that. Okay. Now for deploying, we need to SSH into the system. Now I'll show you how SSH looks like. I think we should have an instance ready by now. Yeah, we have a codebar instance ready, and we'll go to the connect tab in the codebar in the EC2 instance. And here you will see something as SSH client. Okay. Now this is basically a command for you to SSH into your virtual machine. So you just copy this command here, and we'll move to a new terminal. So move to the directory where you have stored your PEM file. I have it in my documents. And I'll paste this command which says SSH. This is the PEM file for my instance. And this is basically the user and the host. And we'll try to SSH into the server now. Now it asks you to confirm connecting, which we'll agree to. This will add our IP to the list of known hosts. Okay. Now this command might not work for you because obviously you don't have the PEM files, but you can build your own EC2 instance and follow along as I showed you. Okay. So now once we are into our servers, what we can do is, first of all, let's push to our GitHub so that our GitHub actions actually deploy our images to Docker Hub. So we'll do git status once. Yeah, we'll do git add, git commit. We'll do Docker files and action, gh action. Okay, and we'll do git push. So once that git push is done, there's one interesting thing that will happen. Now, because we have a GitHub action already, like we have configured a GitHub action, we can actually go to the actions tab and see a action, a workflow in run. It says that it is building. This workflow has been queued. If you go to the action, you can actually see the console of this action. Now, this is a very user-friendly way to debug your actions. Now you can see that Docker login was not possible. Now there's a reason for it. This happened because in the actions, where is it? Yeah, in the deploy.sh, we are using something as Docker user and Docker password. Now, where is this user and password coming from? Well, we can use GitHub secrets for this reason. Now, as you can see, we have secrets.docker password, secret.docker user. Okay. Now, where do we have these secrets? We have these secrets in GitHub settings and secrets. Okay. So you will be led to this action secrets, and you can add new repository secrets here. I'll demonstrate you how to add one secret. Let's say I'll add Docker username, which is for me nodemaster147, and I'll add a secret, new repository secret. I'll add Docker password. Now I'll do this off the screen so that my Docker password is not leaked. So I'll just stop my screen share for a bit. You can add your Docker secrets now. Just take this time to add your secrets, Docker password. Yeah. And then you might have had that PEM file, right? So what I want you to do is take the contents of that PEM file. It will look something like begin RSA key. And you need to copy that PEM file and paste it in the GitHub actions. Okay, so that is something secret that you don't want to show to anyone else. So I'll also do that right now. It'll start with 5 hashes and it'll say begin RSA private key, and it will end by end RSA private key. So I'll add that key right now. Adding the secret, yeah, done. And I can start my screen share again. Yeah, I hope you're able to see my screen again. So I've added 3 secrets right now. We'll add a few more secrets, which will be helping our GitHub action to SSH into the EC2 instance. So we'll add a user name. That user is Ubuntu. It'll be same for everyone. If you are following till now, we'll add another secret, which is port. That value is 22 because SSH works on port number 22. Okay. Now we'll add another secret, which is host. Now this host is what you will get from your EC2 instance console. And here you see this is the user and this is the host. So you copy this part and paste it here. Add a secret. So by the end of this, you should have 6 secrets: Docker password, Docker username, host, key, port, and username. Okay, these are the 6 things that our GitHub action requires. Now that we have these secrets, let's try to rebuild our GitHub action. Okay. This failed because it wasn't able to find Docker password and Docker user. Now we have those secrets, so we'll rerun these jobs. Okay, this takes around 2 to 3 minutes. So yeah. Oh, our Docker login failed again because of some reason, but you get the idea, right? So now what we can do is we can take another terminal and we can build our Docker images. Okay, so we'll cd into the directory, and we have our Docker file here. So we'll do sudo docker build, and we'll tag it. We can tag our images. Basically, what we are doing here is we are building a Docker image, and for building the Docker image, we are performing this step right now. This Docker build file tag new master frontend. Okay, so this is what we are doing. And Docker build, we'll target. So now what Docker will do, it will send the context to Docker daemon. Now Docker daemon is something that runs behind the scene, which is like managing all the Docker environment for you. And as you can see, here are a few steps. These steps are nothing but what we wrote in our Docker file. Let me show you. So we had a Docker file and it looked like this. So we have like 11 steps here. This is a blank line, so 11 steps here. And each steps will be run one by Docker. So as you can see, from node Alpine as builder, this was executed at step 1. Step 2 was working directory, setting the working directory. Step 3 was copying package.json and package log.json. Now it will try to npm install these packages. Now note that these packages will be installed inside the Docker image. Okay, this is not something that is happening on a local system. So these packages that are getting installed are inside the image that we are building that is using this template Docker file. Okay, so yeah, it can take some time to install the npm packages. We'll wait for that. Meanwhile, let's see why our Docker login failed. Anyways. So once we have the Docker file ready, we'll have an image, okay? And using that image, what we can do is that we can use that image to pull it from the server, and from the servers, we can run that image. Now, once we do that, our servers will start running that code which we were seeing on localhost 3000. The same code will run inside a Docker image in the EC2 instance. And once we have the EC2 instance with the port and everything started up, what we want to do is that we want to assign a domain. Okay, so if time permits, I'll also show you how to assign a domain for the EC2 instance. You can use something as Cloudflare for that, where you can buy a domain and you can register it. You can basically change the name servers here, and you can add more subdomains. Let's try to add the subdomain for this instance. You will see a public IP4 address. We'll copy that, and we'll add a subdomain called codebar. Yeah. And we'll provide a IPv4 address. Now this is an A record, okay? Make sure that's a A record and we'll save it. So now that is done, we'll see if our Docker image is successfully tagged. Okay, it is successfully tagged. Now what we'll attempt is to push the file to Docker Hub. So the command for it is sudo docker push, and we'll take the name of the image, sudo docker push, and we'll try to push it. So as you can see, we are attempting to push it, and this is basically all the steps that Docker daemon is performing to push it on Docker Hub. Now, once that is pushed on Docker Hub, what we can do is we can install Docker and Docker Compose on our servers. Now, without having Docker and Docker Compose on a server, we won't be able to run Docker files. So I have a gist made up for that. And if you go to the README file, in the step, copy the Docker compose, yeah, install Docker and Docker compose on EC2 instance, we'll just take this command and paste it. So what this has done is basically it has given us a script. If I show you the contents of the script, this is the script. So basically we are attempting to install Docker, and then we are attempting to install Docker compose. So this is a neat script that can help you take away the pain of installing Docker and Docker compose. We'll just run this script, sudo bash script.sh, and now I'll attempt to install Docker. Now here you see, because of the use of these scripts, our life is so easy, right? We don't need to manually have these commands input in the EC2 instance, and we can get away with all the pain with just one file. So in the meanwhile, I think it should be pushed. Yeah. So as you can see, the Docker image is successfully pushed, and it has given us a SHA key, which is a unique key for every image. And we'll just wait for Docker to EC2 instance to install Docker. Okay. Oh, so much waiting. Yeah, Docker is done. It's unpacking container.io, which is nice. Docker CLI is installed. Yep, symlinks are getting created. Yeah, there we have it. So now we have Docker installed. We'll check by Docker ps if it is installed correctly, which it is, because we see that there are no files currently. So we'll pull the pushed image. We'll do sudo docker pull, and we'll paste the image name. We are now pulling an image from Docker Hub, which we pushed it from the local right now. It'll take around a second. Yeah. And now we'll basically want to run the Docker image. So we'll do sudo docker run, and we'll provide a port map, which we can do by -p. And what we want to map is 80 with 3000. So 80 is that what we referred in the EC2 instance security group. And 3000 is the thing that we referred in the front end image. So now Docker is started. And if I go to codebar dot 8lines.club, I should see the React app. Voila, there you have it. Now, with GitHub Actions, what you can do is basically with one git push, you can make changes to this app, and everything that we did here would be automated. So this is how you basically build from development to production. Now, this is at production. This site is available globally. You can also check this out at here, right? So yeah, I think that's it from my side. Great session, like great audience. Thank you for having. Bye bye.